So if we use a vector-valued function approach, writing equations of circles in 3 dimensions is quite easy. So I'm going to do an example, and I'm going to have my circles just be parallel to one of the coordinate planes. So either the xy plane, the xz plane, or the yz plane. Okay? So the first example, we're going to have a radius of 5. It's going to be parallel to the xy plane, but I want its center to be at the point 2, 3, 4. Okay? So if I think about this whole parallel to the xy plane, that means, right, I could find the equation of the circle that's in the xy plane. So let z equal 0. So let's just let z equal 0 for now. Okay? And then we're going to write the parametric version, right, of the circle then with a radius of 5. Right? So I'm going to let that vector-valued function, I'm going to parameterize the circle with a radius of 5. So one version would be 5 cosine t, 5 sine t. You could swap those. You could make them negative. Doesn't matter. Z I'm going to let be 0 because that'll just put it down here, right, in the xy plane. So here's the circle in the xy plane, z equals 0. Okay. In order to move it so that it is at this, has the point 2, 3, 4 as its center, the way we're going to do that is we're just going to add, we're going to find the vector that goes from the center, right? So we're going to find the position vector for the center. So let's call that, how about R0? Right, so 2, 3, 4. And we just need to add these two together. So the circle will be given by the coordinates, so 2 plus 5 cosine t, comma, 3 plus 5 sine t, and then 4 plus 0. So the idea of treating, right, the x position independently from the y, independently from the z, makes it really nice just to move it. Right? So I wanted all of my x values, right, that used to be given by, right, 5 cos t to be moved 2 to the right. So I'm just going to add 2 to all of those points, and it shifts all of them, right, 2 to the right. And then the same thing with the y and the z. Okay, second example. So this time the radius is 1, and I'm going to be parallel to the xz plane, and then I want this to be my center. Okay. So if I'm going to be parallel to the xz plane, that means we're going to let y equal 0. Okay. So being in that xz plane. So when we go to find our parameterization, right, our initial parameterization, we'll have cosine t for the x, a 0 for the y, sine t for the z. Right, swapping the cosine and the sine, it changes where you start. That's all, right? But the same path is going to be plotted out. Let's go ahead and find an R0 vector, that position vector to get us to the center. So that'll be -3, 4, 2. Okay. And then we're just going to add those two together to get the vector that describes, right, that circle that's parallel to the xz plane with a radius of 1. So that was the one that was here in front of the sine and the cosine. Okay. But now the center, right, is going to move. So -3 plus cosine t, 4 plus 0, or just 4. And then 2 plus sine